Okay, so our last speaker in this conference, who will provide his concluding perspective, will be Professor Gabriel Motzkin, who is the director of the Van Leer Institute, and so is an important part in providing the pleasant atmosphere of this conference. Gabi is, by professional expertise, a philosopher and an historian. In this context, his fields of interest are the philosophy of history, secularization theory, cognitive science, memory theory, and Heidegger. He wrote the book Time and Transcendence, Secular History, the Catholic Reaction and the Rediscovery of the Future in 1992, and co-edited several books like The Voyages of Ideas of People and a book about moral approaches to genocide practices. This may give you, some of you, the impression that Gabi's field of specialty is quite remote from the fields of the rest of the participants in this conference, various as they already are. However, Gabi's knowledge is enormous in a variety of fields, and it is a constant source of awe for me to realize how wide are the topics in which he has original and well-informed views. So today, Gabi will speak about the question of, can there be a new metaphysics of spacetime? Please.
All this is quite long. I do not claim to have any particular knowledge of physics, but I do think that it is important that people think about physics even if they don't have as much knowledge as the specialists would like. Otherwise, there will soon be no physicists. So there's a good reason for that. Now, we have talked in this conference about three things, one of which is Einstein's reception. The other is contemporary theories about physics. And the third is about how the mind understands physics. That was the third topic, and I will contribute to, if at all, to this third topic. Now I have one more prefatory remark, and that is about strong and weak theories of mind. Now, the most prevalent theory of mind that exists is what I call the weak megalomaniac category of mind. The weak megalomaniac category is a Kantian theory which starts out by saying, no, we can only know appearances. We can't know how things really are. And then Fichte and Hegel and all those other well-known philosophers say, well, let's just change the equation and say that, in fact, what we think is how things are. So that if I say the word table, that's a table. But you see, this is the kind of theory that goes on into saying that there are no quantum events if there are no humans to think about them. This is another variety of weak megalomania, and it comes from a fundamental feeling of inadequacy about the world, an attempt to get power over it in a different way. Now then there are the strong and limited theories, and the strong or limited theories say something like this, that we can say something about nature without transforming it. That's a very important conclusion, because the whole point is, can you say anything about nature at all? Even this sentence that that you're unfortunately listening to is can you say anything about nature without immediately transforming it? And if you can't, then you've got, I think, a problem. So I'm going to start out, actually in my talk, by not adopting the position I will get to at the end, and explain what, from my point of view, is the problem, and seem to side with those people who see a problem, and then I'm going to reverse the table. Okay, now my talk is not, can there be a metaphysics of spacetime? It's called Writing the Photon, Cosmic Space and Time and Human Space and Time. Eugene Wigner once wondered why it is that human beings can understand the cosmos. At first, the answer seems to be that human beings can understand the cosmos because they can understand mathematics. And they can understand mathematics because they can understand logic. The underlying assumption is that the cosmos also obeys the rules of mathematics and, to some degree, of logic. In one way, however, there seems to be a giant discrepancy between our understanding of the cosmos and of our own place in the world, and this is one where it is difficult for us to make a bridging assumption between our minds and the world. This discrepancy, as you all know, has to do with time. Our human time is divided into tenses, past, present, and future. This divide is so dramatic that some philosophers have taken tense to be more basic than the rules of before and after, i.e. the idea of time as successive. Yet it seems that when we turn to the cosmos, it does not make much sense to think of tense time. Sure, we are now seeing light emanating from the past, and we can predict a path into the future that will place us in a thus and so relation to our galaxy. We can plot that. We do not really know what will happen when the Andromeda galaxy will collide with ours, although it is safe to say that by that point our planet will no longer be a host to life. However, all these descriptions of past and future are extensions on a line from a present moment, which is somewhat fictionally presupposed to be right now. Hence, we look for events and compare them in terms of a linear scale of before and after. This is true even if we were to believe that time does not flow by at a constant pace, but rather that it changes along with the rate of the expansion of the universe. We have no language for varying the scale of time by which we measure events, even though we do know that time is not invariant. Many theories of human time do not accept this picture at all. Let's just take one of them, that of a reasonably well-known German philosopher who will be mentioned for the first time in this conference, Edmund Husserl. Husserl believed that your most basic experience of time is your capacity to understand this sentence. To do that, you have to retain the words long enough in your mind so that you can understand what is being said. He called this time retention. Once the sentence is complete, it vanishes. It does not function like a photon that travels endlessly through the universe, apparently preserving a remote past into some remote future. If you want to call up this sentence, once it has vanished, you have to reproduce it through memory. However, that act of reproduction is in your present. Once you have reproduced it, you can string it together with a bunch of other sentences, and only then do you get succession. In other words, to get succession, you first have to be present and past, then you have to forget the present, then you have to recall the particular present-past unit, and then you can string it together in a succession of such units. It's a long process. Succession requires present, retention, past, memory, reproduction, and finally, succession. One could claim that this sequence is merely a sign of human insufficiency or dumbness, and that real intelligence and understanding of the physical world only begins with succession. Whether or not this claim about human stupidity is true, the question remains: how do you bridge between the time of your understanding and the time of the cosmos, given that the two appear to be quite different? This problem can be posed for any human condition, but is more acute for time for the following reason, namely, my time is attached to me, your time is attached to me, just as the cosmos is pervaded by time. Our temptation would be to find a formal way of linking my time and universal time by detaching them from that of which they are the time, i.e. the cosmos and human beings, and then showing how one time relates to the other. However, this is not possible for human time. My time cannot be detached from me, and I don't think it can work for cosmic time either. Namely, human time is uniquely your time, and it only exists with and you personally. And in the same way, cosmic time varies in different regions. There are two stories that can be told here. The first is the story of how human time arises on the basis of physical time. The second is the story of how physical time can be educed, brought out, from human time. However, we are not in a neutral position as observers. It is not as if we can view both kinds of time from a neutral perspective. We ourselves are human. And so our path will be always one of reduction from human time to cosmic time. Nonetheless, we still have to ask, how is it possible that on the basis of cosmic time, something like human time is even possible? Human time has two features which, for the moment, we are not sure that cosmic time shares. First, we know that we are finite in both directions, and not just in one direction, birth and death. Second, we tend to view our time as being composed of one real box and two imaginary boxes. The imaginary boxes are the not yet and the no longer, the future and the past, which for us do not exist right now. The real box would then be the present. Now, this has been discussed at length by many thinkers, but it is clear that we do place our experience in such boxes. How these boxes relate to our finitude in both directions is another question. Notably, here's another somewhat infamous, but somewhat notorious German thinker, Martin Heidegger, and he conceived of human experience as being finite only in one direction, towards the future, and then he related tense time to this one limit. He did not believe in the existence of successive time. The traditional and religious story of human life, of course, is the reverse. The soul has a beginning, but it has no end. In that, the religious story of human life looks much like the current astrophysical theory of the cosmos, which according to present theory is supposed to have a beginning but no end. There are weighty issues with cosmic time that makes this story of succession a little more complicated. For example, light is supposed to have escaped the cosmic brew only, 380,000 years after the beginning. So how can we measure the time of the first 380,000 years? If time is a consequence of the motion of particles, then it is not an external measure. The second issue, as you know, has to deal with black holes. Matter is pulled into the black hole singularity, nothing can escape, perhaps information is lost, and time seems to stop. Now, the black hole singularity may be very different from the first 380,000 years, but both in different ways limit time. Remember that time has to escape the beginning, much like when one of a pair of particles falls into a black hole, the other may escape into infinity. It is not just that we are here because something has escaped the original brew, it is that space and time are here because something has escaped the original brew. But what does all this mean? It means that whatever our view of time, a conception of time as succession cannot include time's limit experiences, which, whatever they are not ordered according to succession, because in both cases, in both the case of the original soup and in the case of the black hole, one cannot really speak of succession. Now, when we do speak of time as succession, we have another quite precise idea in mind. It is the idea of causality, and we've heard about that. We cannot make any sense, I think, of the idea of causality without the idea of succession, because our idea of causality, i.e. that something causes something else, requires two things to be located in a sequence such that there is a cause and there is an effect. But the point is that this mechanical idea of causality, which may break down when there is no successive time, does not work out at all for human life, in which the flapping wings of a butterfly in China may cause war to break out between Liechtenstein and Switzerland. In other words, human events are overdetermined in such a way that we can never say, for example, that the cause of World War I was X. I can fill out X if you want to. A favorite question of doctoral examiners in the field of modern history, in which I did my doctorate, is to ask the person who is being examined to list all the causes of World War I and then to rank them and to explain the reasons for her ranking them in this way. Human life has many different causes, none of which currently exists. Unlike the story about physical particles, in which they are supposed to have one cause and that the cause is also supposed to continue to exist. In other words, the basic assumption of physics, as you all know, is that atoms are preserved even when organisms die. What happens is an exchange of atoms between one mode of organization and another. However, the basic assumption of human life is that the past vanishes. Moreover, we are so situated that we very rarely experience this vanishing directly. Try as time is flowing by to experience how time is escaping from you. And when we do so, there are those limit experiences where we suddenly see it, and it's very weird, since we never notice that things are disappearing. You will notice that the model of succession along a two-dimensional line, one-dimensional line, actually allows for the preservation of past moments as part of the line. In contrast, in the model of tense, when a moment is placed in the box called past, it has vanished from our perception just like a photon in a black hole. That is to say, we cannot tell if it continues to exist or not. Now, we do have an experience of a cosmos that seems to contradict this human experience. When light from stars arrives here, it is already at the past, at its point of departure. Now, what has vanished and what exists? In what way does this light exist in the now? And in what way is it preserved because it exists in the now? You will readily see that there are two different experiences here. On the one hand, the photon is no longer where it was X light years ago, and on the other hand, it is here only for an observer who observes it. That may seem controversial, since there could be a now in which the photon arrives despite there being no observer around. But that photon goes on until and on until and if it is stopped. And from the point of view of the photon, it seems to appear, I'm going to contradict this in a minute, that now is not a meaningful category. The photon is constantly in motion such that its own now is all along its path. It is only from the point of view of an external measurement that there is a now at a given point along its path. The external nowness at a moment of the photon exists only for the observer, the external nowness. The position of the photon exists only in terms of its observed nowness, since it has no position so long as it is moving. Now, this stationary quality exists because for the measurer, who in this case may be a human being, there's a stationary and dynamic quality to his existence. In our case, this double experience relates to our dynamic quality in relation to ourselves and our need to hold the world stationary as we gauge the world. In turn, this movement is reversed in reality, since it is we who are moving slowly through time and space, slower than the photon, I think, while our environment would seem to be stationary in relation to our movement. However, we need to think that we are stationary and that the world is in motion. That is because our shifting point of view is experienced by us as a continuous constant. This inner experience of nowness is at the core of our being. This is true whether or not we are directed to some finite future. The point about this inner experience of nowness is that all previous nows have vanished as nows. Whether or not they continue to exist, they cannot continue to exist as being now. So we apprehend the photon right now, and that apprehension vanishes whether or not the photon itself has vanished. In this sense, the photon emanating from the past can be preserved, but it cannot be preserved as being part of a human now. There's one big difference between the photon and life. As you know, the photon lights in all directions, not only in the direction in which it is traveling. Otherwise, we would not have Doppler redshifts. Thus, the question about light is that of the direction in which it is traveling. Human beings do not face all directions. They face only the future. They face the future precisely because they are living. Living beings need to stay alive and to reproduce in their constant war against entropy. Threats to both life and reproduction can only come from the future, since if a threat comes from the past, either it is not a threat or it really is coming from the future. In other words, even if human beings could, as it were, face the past, it would not be useful for them unless threats and dangers could also come from the past. Now imagine that you are traveling on a photon. You are traveling in one direction, but you are, as it were, radiating in all directions at the same time, so you can see not only where you're going, but where you were. In fact, it's a bit more complicated, since the moment that light leaves where it is moving from, for example, a star, it is carrying that moment to the location it is going to. Moreover, it is doing this even in the direction in which it is not going, that from which it is receding. It can do this because it itself is a now, encapsulating its own time into where it alights, irrespective of whether its origin is moving away from or towards where the light alights. Thus, it makes only qualified sense to say that the light from Alpha Centauri is X light years old. It started from there X light years ago, but it really is here right now. In other words, light is constantly restructuring the relations between past, present, and future so that it remains in the present. Seen from the perspective of a light photon, spaces travel through time. That is exactly the way space is experienced by a human being. If, however, we look at that photon as an object, then time is traveled through space. If we look at space from a subjective point of view, then time is vanishing. However, from a time perspective, space is not vanishing in the way that time vanishes for a human being, but rather space is expanding. Thus, as time is experienced from one point of view of vanishing, space is experienced as expanding. Let's try to explain this. If you are on the photon, writing the photon, you are experiencing your time as nowness, and you cannot aggregate your elapsed or future time by reference to an external measure. If I measure the velocity of the photon, I have to measure it from an external point of view. My point is that this act of measuring shifts the relations between time and space, since I am measuring time through space and space through time. Moreover, I assume in measuring that I am not on the photon. If I am writing the photon, I'm ever lonelier, since I don't notice the lapse of time, but I do notice the expansion of space. If light can be used as a measure for space, then it itself is time. Now, why is it that the experience of human beings is more like light than it is like that of objects? One reason is that human beings do not naturally experience the world as something to be measured quantitatively. Indeed, it took them a long time to realize that the world does not have the capabilities that they possess. Birds were supposed to have language, and everything animate, including plants, was supposed to be ensouled. So long as they were ensouled, the phenomena composing the world could not be measured, since they were acting upon us much as we imagine other human beings act and react to us. Only when we were able to detach measure from the phenomenal world by thinking that measures such as velocity could be applied to objects did we begin to escape this conception. Our earliest tendency was to imagine that something like velocity had an essence, i.e. that ideas such as velocity exist in and for themselves apart from the objects that they are measuring. However, getting rid of this conception meant that there is no absolute velocity, but rather velocity is an attribute of individual objects that can be compared on this one dimension. That kind of measure does not exclude other measures that compare objects. It is only one of them. We then fell into the error of believing that what cannot be measured does not exist. In contrast, psychologists know, this is a sentence in the first-year psychology textbook, that not everything that can be measured exists. Psychologists detect variations and correlations that are only effects of the question that they are asking. They don't always know that the question which they are asking relates to anything that really exists. Now, one phenomenon I cannot measure is my sense of being myself. The reason is that it is incomparable to your sense of being yourself, since it assumes my uniqueness or singularity as a phenomenon. We also believe in singularities in the universe. You've heard about that. Many believe that the universe itself originated in such a singularity. Black holes are also supposed to be such singularities. We can compare singularities and say that this black hole is bigger than that black hole, but from the point of view of a black hole, it is a singularity, and therefore basically incomparable to any other black hole. Black holes don't look at other black holes, I think. However, not only black holes are singularities. Any object, any particle, if it were viewed subjectively, would also be a singularity. Now, we don't usually ascribe subjectivity to anything except ourselves, for we feel that we would fall back into a magical experience of the world if we were to do so. But what we can do is take any specific entity or particle and ask how the world looks from that point of view. That procedure is also a fiction because we do not ascribe self-consciousness to particles. What I am arguing is that subjectivity is not irreducible. Subjectivity is rather an actualization of one of the possibilities afforded to us by the physics of the cosmos. This possibility involves believing that an object can have a perspective. However, our measuring tools are inadequate to capture this possibility, since they measure attributes of the particle according to some external standard of measure. this statement is not a mystical statement. All it says is that the world appears as different from every specific or individual point of view. We can then ask how the world appears from a given point of view. And here there emerges a fundamental difference. Namely, the world appears different from the point of view of the measurer and from the point of view of what is being measured. I am arguing that even the sense of time appears to be different. My suggestion is that from the point of view of a particle, it appears to be an endless now, just as I seem to myself to be constantly alive. Now and then, or not yet, only makes sense in terms of this constant life. Once I am dead, there is no now. How do you distinguish between now and then if you are in an endless now? Can you have a sense of time at all, whether as time or as succession? Traditional philosophers had a name for an endless now. They called it eternity. In eternity, there is neither tense nor succession. Philosophers argued that from God's point of view, everything is happening at once. They then had to solve the problem of causality, since in a simultaneous world there can be no causes and no effects. Indeed, they veered close to this position in believing that all effects were somehow contained in the causes, so that a causal chain was independent of a time measure. That's the traditional belief. In other words, one can only specify time as we do it from an external point of view, saying that a photon began its journey X years ago. According to relativity, every photon is from its own point of view in such an endless now. However, every photon is also finite, at least in one direction. The point is this: if it were not finite, it would not be specific. The question we need to ask is whether the photon is finite in the other direction. And our current answer is that it is not. When we speak parts of the universe dropping off from the horizon that we can see, we do not mean that the photons that come from that part of the universe have changed. Either we mean that the universe is expanding faster than the speed of light, which at present we cannot allow, or we mean that the expansion of the universe means that the photon can no longer arrive at where we are. However, it is then still arriving somewhere else. Moreover, its arrival is in one sense but a metaphor. It is in the nature of the photon that it is arriving everywhere in the vicinity. If there were another planet like Earth, a few million, miles, kilometers, in either direction, the photon sent out from some star would arrive there as well as here. So it is not right to speak of the photon as having a distinct goal. That means that when you are riding the photon, you first do not know where the photon ends, and second, you cannot a priori assume that it ends, since it just keeps moving until it hits something. However, as noted, you do know that the photon had a beginning. Therefore, you do have a limited sense of finitude. Therefore, what you obtain is an endless now or simultaneity, plus one border a beginning. There is a place from which your photon has started to move. In that sense, you have a now which is transparent in all directions, and a then which you cannot even imagine, since the photon did not exist at that time. Against this position, it could, I suppose, be argued that the photons were all there, but they were imprisoned in the primordial brew until they were able to escape. Consider what that would mean for a moment. It would mean that every point in a thermonuclear combustion, such as takes place in stars, had a pre-existence in something else. You could not have a beginning of light radiating from the thermonuclear combustion. Then the questions would arise. What and where was the photon before it emanated from the nuclear fusion? If you are riding that photon, however, it makes no difference, since your journey begins as a time journey with a definite point of origin. It follows that what is obtained is an internal nowness with a point of origin that may or may not have a point of termination. Again, that is very much like our experience of human life, where we have a point of origin that we cannot remember. If any of you can remember it, please let me know. And that we do not know firsthand, and the point of termination, which while is certain for us, we experience as uncertain. Most of us do not know when we're going to die. Until we die, we do have a total consciousness of being alive, with the future appearing as infinite or unbounded to a centenarian, just as it is to a young child. What all this means is that there is a deep homology between our consciousness and what we deem to be the physical world. It goes beyond our ability to analyze equations. It rather goes to the way in which we experience time. which is our experience of the invisible and somewhat ineffable. I do not know if this homology is mediated by our bodies. It may also be that the reason for this homology is that we structure the world according to our consciousness. Now, while that is certainly true, the physical world that we have discovered is not at all the world of our perception. It has nothing to do with 19th century sense data. It has rather to do with our basic intuitions of time and space, which turn out not to be simultaneity for space and succession for time, as Kant thought. Our intuitions turn out to be simultaneity for time and succession for space. These are the intuitions of our experience of consciousness when it is considered apart from perception. I do not know the reason for this homology, although I can speculate about it. What I do know is that Wigner was both right and wrong. It is true that our mind is like the universe, but that is not because we can understand equations and because the universe functions according to the laws of mathematics. We can imagine a change in the velocity of time, and we can also imagine that time comes in discontinuous clumps, although it is hard for us to prove it. It is a question whether anything we can imagine follows the laws that govern the universe or whether we can break those laws in our imagination. I tend to think that we cannot break those laws in our thinking, but at some level how we think is coordinated with how things are. We can measure and express that relationship in mathematics, but the point about that relation is something else. We can imagine a giant machine which would be, as it were, known by all the parts. If you are a part and you are conscious, you begin to explore the whole, and you discover that you have a function in this whole, a function that you did not imagine when you set out to explore the machine. That function is why you are there. In that sense, the homology between our experience of space-time and our partially demonstrable idea about the nature of that space-time is the best evidence that our being conscious is not completely accidental. Thank you. Carla. Microphone.
Can you elaborate on the last paragraph?
On the last paragraph. Yes, I'm not trying to be a theologian or anything like this. All I'm trying to say is that if you have it's a very simple point, which is if you either have there are two approaches. We heard one that was that there's a complete discontinuity between my experience of time and what we today think about cosmic time. Now, if you do that, then you think human time is sort of a soft time, and you have to then have different rules with it. And then you also one day have to get conversion principles for how we got human time out of cosmic time, or vice versa, how we are able to think of cosmic time about human time. I think that maybe it's time that we start using our physical theories to reinterpret how our own organism and how our mind works, and then to look what are the analogies between what we know about cosmic time, and soft as they are, they're not going to be, equations and everything. Still, we may get further along with that. And then you can say that the fact of our consciousness, in other words, what I'm suggesting is that our structure of consciousness is not a contingent fact just of Darwinist survival, because in some way, because we are ensembles of atoms and molecules and all the rest, we follow physical laws. So why does our consciousness of time have to be different from the consciousness of our time up here, and so on? I think that if we went that way, maybe we could get further. It's just a suggestion.
Thank you.
I think that was very thought stimulating, and I'm still sort of rings in my mind. I have a specific question that goes in a similar direction as far as the homology is concerned. Of course, there are different, culturally very diverse way of looking at time, and probably also very different ways to experience human times. Not so much just between individual human beings, but also in different human cultures. So, you said there's a kind of a soft bridge between cosmic time and human time. But what do you make of this cultural diversity?
I'll tell you what I make of it. It's not what I make of it. There was now unfortunately dead a British anthropologist called Alfred Gell, who wrote a book called The Anthropology of Time, and he lived for several years in Indonesia and then for several years in an Indian village. And against all the theories of Gurevich and the people that you're referring to, he came up with a conclusion in some very basic ways. Certain aspects of the concepts of time are universal, like the sense of before and after. It is true that in societies where people can't count, then they have no memory of a distant past or a remote future. That's completely correct. And there are lots of societies where people can't count beyond N or X or whatever it is. That's true. But when you tell somebody, you know, I'll see you tonight, they understand that means I'll see you tonight. You know, it's the kinds of things about which people think are magical is something quite different. It's the relation of dreams to reality. Because if I dreamt that you stole from me 5 bananas, in some cultures you have to pay me for those 5 bananas. That's the kind of thing where there's a lot of cultural variation. And that's a difficult frontier for us to achieve, the frontier between dreams and reality. Just read the book Genesis of the Bible and you see how tough that is. And because people think that their dreams are real. That has nothing to do with the concept of time. It may have something to do with the concept of repetition. I wake up in the same old bed in the same old bedroom every day. Oh, I was here before. But beyond that, but that's a very different thing. So I am not sure that there is this diversity if you go back to fundamental concepts. There are people.
Since this is about Einstein, so let's bring Einstein into the discussion. And the first session, we discussed this Appendix 5 of this popular booklet of Einstein. And in that appendix, there is quite a detailed discussion of the psychological perception of time, and there is the concept of succession as a basis of that. He does not have this sophisticated picture of Husserl with retention and all that, but there is a succession, and the succession is a certain order of events that we psychologically sense. But then Einstein makes an interesting point, and that's something which maybe see how that fits into your picture, that there is a basic difference between the psychological succession and the objective succession of events. And the reason, the source of that difference is that psychologically we think about time as separated from space. But in order to get this objective physical succession, we have to know where the events are located in space.
I think that's a fine thing, but I don't think it's true. And I'll tell you why I don't think it's true. I think that actually I adopt towards human life a Darwinist perspective, which is what I tried to point out, which is I think that it would not be useful for you to be time asymmetric, because then you could not protect your own living organism. And if you were time asymmetric, then you would not know whether the threat, whether there's a tiger coming into this room and whether he wants to eat you or not. So that there's a large survivability to having one direction of time. It's a very large way for you to survive. And I think that, to my mind, is convincing, because it doesn't mean that I have to separate time and space. Now, we have evolved not to have a time consciousness. We have evolved to have a space consciousness, because we have to know from where threats are coming. And that's much more important to a primitive ape than it is to figure out whether he's older or younger or what he remembers of his childhood or anything else. And because it goes that way, therefore he has to derive his concept of time from his concept of space in a highly sophisticated move later. I am not sure that the original primordial primate situation is one in which we have a unified concept of time at all. And that's just the way we are. Now, I also think that, before Einstein, there were several centuries in which people thought that time was much more important than space. Kant calls it the form of inner intuition in space, the form of outer intuition. Guess which is more important, inner intuition or outer intuition for Kant? And I think that, what you have is the sudden idea that human beings are really, in that sense, not as Proust would have it, time-oriented, but space-oriented in a fundamental way. But, however, that means that in that way that you can draw an analogy between that and some vague sense of what's going on in the universe, because that may be true of the universe too. I'd leave that to you.
Very interesting. I'm speechless.
No reason to be.
Because a physicist, even before he becomes a physicist, he thinks about time all the time. But there's a difference. A physicist talks about intervals of time, not the flowing of time. And that maybe you can also incorporate in your beautiful analysis of how human relates to objects.
Okay, I can say one thing about that, and I don't know if it relates to your question, but it's this. Much has been made of the fact that we are continuous. But, you know, I don't think that I sense myself as continuous. I'm right here, right now. I don't know that I'm continuous with who I was this morning when I got up and had a cup of coffee. I remember having the cup of coffee, but it's not as part of a continuity. So this idea of temporal continuity may in fact be cultural in some way. Now, I think that in the same way, you know, if you look at what little I know of physics, one of the big assumptions is the continuity of time, but there are physicists who are not quite completely happy with that because it leads to all kinds of problems. So I think there is an issue about continuity and what flow means, and whether flow is some kind of illusion that we provide the world around us for all kinds of reasons, and is this illusion original or appended? In other words, that's what Jürgen would call cultural. In other words, what, you know, because in a world, again, think back to the original human being. Threats, by their nature, are discontinuous. You don't know when and where you're going to encounter the next tiger. Most of us think it's not going to be in 10 minutes from here. I think that, Robert, did you have a question, Robert?
Yeah, I just may not have any.
That's okay.
I wasn't sure I understood what you were saying when you're saying we move from thinking of time as succession and space as simultaneity to the opposite. Or did I just get that backwards?
I just said, no, I didn't say we moved. I said that, you know, that, no, you got it right. I said that in Kant, you know, succession is internal, and simultaneity is the coincidence of 2 points that you experience simultaneity, and that's what gives you your sense of space. So simultaneity is of space. Now, I say that we live in a cosmos that I think, perhaps because our affection by physics is very different, that we think that our outer sense is succession and our inner sense is simultaneous. In other words, that we're much more spatial than temporal. I don't think that we have the same fascination with temporal patterns that Proust, for instance, did or something like that. And I'm talking culturally now, not philosophically. I think Carlo. And then...
Thanks.
It's a comment and a question. The comment about your how much we are naturally wired, I would say, to have the intuition of space. I just want to mention that one of the big hits in neuroscience this summer was the discovery of so-called grid neurons.
What kind of neurons? Grid?
Grid. There have been a discovery that has had a lot of impact, which is in the brain of primates, but presumably mammals. There are actually neurons that are dedicated to literally map space around. So it seems to we are wired to have an intuition about space around us in a way that is being being studied right now by the neuroscientists.
Well, I think that's a very important point, because I think that, you know, one of the things is that if it were useful to us to perceive time, then we would perceive time. So why don't we perceive time? Because it doesn't help our survival.
This is I'm very fascinated by this suggestion enormously. So there's another thing I was very fascinated in what you said, and that's my question. And maybe you can say a little bit more. You hinted about that, and in fact, you suggested that what is interesting, it might be to look at a perspective on the world from the perspective of subsystems of the world, which you clearly separated from the problem of consciousness, of course, but on the other hand, it might be something that is that comes before, that is essential for the building up of consciousness at some point. Can you say something more about this perspectival?
I've been fascinated for years with the figure of perspective, and I started out with it in history and in historical thought, and then I generalized the thing because I realized that you always have to ask not how it looks from your point of view, but from the point of view of whatever particle, and perspective here is used metaphorically. I don't think photons have self-consciousness or anything
of course,
like that. But I think that you can say how the world appears to you if you were, as I put it, riding the photon, if you were along for the ride. And I think that that's very important because some of the problems we have of measurement and being measured have to do that we're always looking at it from the perspective, from one perspective and not from the other perspective, so that if we were looking at, it from the other perspective, we might get a different point of view. I don't want to speculate about the physics of which I'm blissfully or not so blissfully ignorant. I think I probably chose the wrong career, but but I do think that if you look at it, one of the things you have to think is not only how the measurer looks at the measured, but how does the measurer, if they could, appear to what is being measured, because that would be the sum of your experience in both directions. And of course, that we experience, we say this goes this way and that goes that way, but we don't say what's happening to the measurer from the point of view of the particle, but maybe that the particle has also a point of view on the measurer. I don't mean on me, I mean on the point from which is being measured. And but I think that perspectival analysis is very important because for us, if we get a sense of time, it's through our sense of perspective, not of succession. That was long ago. That was yesterday. This will be tomorrow. This will be. In other words, we make all kinds of statements that why is it that time appears to go slower and faster? It's all a question of perspective for us, and I think that perspective may help us perhaps solve some of our problems. I don't know if I have anything more to say about it.
Thanks. Thank you.
Okay. You have to talk to the mic because otherwise nobody will understand you because we're orally challenged.
Whether space-time are real or metaphysics by analogy, otherwise what?
As a what? Otherwise. Okay, look. This is one of these debates. I happen to think that space-time is real. I happen to think we live in a real universe. I don't think the universe is in my head. I'm not going to go into my justifications for it right now. I think that the laws of physics are true for that which they can measure, and we don't know if it's true for the things they can't measure yet, but we think it's true for what they can measure, and therefore I think that the first road has to be not how I think about physics, but how physics makes it possible for me to think. And that I have to do before I think about how I think about physics. I have to be able to get from the direction where I say, what is it about physics that enables me to be the kind of being that I am? And only when I go through that question can I then say, how do I reconstruct it? Obviously, in a learning process, it's the other way around. I learn about the world because I first think the world is flat, and then I'm told that it's round, and then I'm told that it's a banana, and eventually I figure it out. But that is not, but that's, if the rules of physics are true, they must be rules that make it possible for me to be and to think. And so I think that's the direction which is more fruitful to go into. That's the compliment I'm paying to the physicists, as if they care. And, okay.
Thank you very much. We'll end here.
Okay.